Hi, hello. Thank you, everyone. Um, it was a great opportunity for me to present my research at this online carbon neutral conference. And let's get started. Thank you, Tara, for introducing me. Just fixing my monitors real quick. Just give me a moment. Okay. Yes, I think we're good to go. Today I'm going to present my research on measuring the impacts of sidewalks on public transit, first mile, last mile accessibility, and their association with social and demographic factors. So here I'm working as the lead author. I also have Liu, who used to be a PhD student at the Ohio State University, but now he is assistant professor at the Auburn University. We also have Harvey Miller, our supervisor at the Ohio State University, as the supervisor of this research. So can you please change the slide to the next? Thank you. So the big picture we wanted to see is that first, I want to introduce the first mile, last mile concept with you guys. So when we have a transit trip, we have to go from our home or any origin location to the nearest bus stop. So this distance is considered as the first mile distance. Also, when we go to reach to the to our destination and we get off the bus and go to our main destination, that is called the last mile. So these two parts are very essential in the transit trips, because in most cases we just think about the transit travel length, and we care about improving its efficiency, comfort, service quality, and a lot of things. But if these two connectors are not good enough, then sometimes this can be very discouraging for people to use transit in the whole. So we wanted to see the this first mile and last mile accessibility, and how that is affected by the missing sidewalk. So in our city, we have the sidewalks missing in many places. Maybe we don't mind, but there are a lot of users who are sidewalk reliant user who are probably disabled, who are probably use wheelchair, who are probably very much safety concerned. They don't want to share the road with the heavy traffic. They want a separate sidewalk to feel more safe, to feel safer to get to the transit stop. So let's get to the next slide. So that's why we formulated these objectives. Our main goal is to see the sidewalk gaps where we don't have the sidewalks, and the second is to measure the accessibility gap between the road network and the sidewalk restricted network. This is pretty important to elaborate. So when we focus on the road network, we don't care about the sidewalk gaps. We assume that we can go anywhere, wherever there are roads, we can walk there. But if we focus on sidewalk restricted network, then our ability to travel minimizes. So we created a sidewalk restricted network, and we assume that this could be some choice for those groups that I just mentioned. And that should be the ideal case in urban planning, that we want no sidewalk gap in the city. We want like every street occupied with sidewalk, at least one side, or at least two, that can get the person from any place in the city to the nearest bus stop. So what is the current case and what is the ideal case? So we compared these two cases and by with the accessibility, and found the gaps. And finally, we when we measured the gap, then we tried to see how the sociodemographic classes are distributed in association with that gaps. So please next. So this is our methodology. It is simple, but it is very much effective. In the right picture, I showed two instances where we have the discontinuity of the sidewalk. So you have a sidewalk. You were using a wheelchair and wanted to go to a transit stop, but now all of a sudden the sidewalk stops. So you have to share the road. So that's the case of many places in Columbus. I choose Columbus as as our case study area. So in the left picture, I showed two polygons. The green polygon is um, the star is the bus stop. The green polygon is the pet shed, or how much area you can travel within a certain amount of time with the sidewalk network. Excuse me. And the yellow boundary is the travel pet shed with the same amount of time by the road network. So in many cases, you can travel a lot more if you don't mind the accessibility sidewalk gap. But if you are restricted to the sidewalk and if you stop right there where you don't have the sidewalk or it continues, then you have the limited area. So these two areas we call the PSR in the second equation of the CPS. We call the PSR is the pet shed by road and PSS is the pet shed by sidewalk. We just take their differences and we name it comparative pet shed or CPS. So that's one measure. They're very simple again, but effective to see the spatial distribution of the gaps. And the second thing we wanted to see that is again simple. We from each bus stop. Sorry, my pollen things. So from each bus stop, we measured the healthcare accessibility with these two networks, and grocery accessibility again with these two networks, and just found if the accessibility with the sidewalk network is less than that by the road network. If this is less, then we just flag it by okay, less access, and if it is not less or equal, then okay, equal access. So in this way we flag we measure every bus stop in Columbus, around 3,000 bus stop in Columbus, with these two categories, if they provide less access with the sidewalk network or equal or more access. Mostly equal access, very unlikely to provide more access. So please, the next slide. So these are the findings. We start with the excess gap. The blue colors, lower the number, the less the gap, the better. So the blue ones are better. We see the city center has like very low accessibility gap. So here by the number, if this is 0.17, it means 17% gap. So if you look at the yellow colors, this is up to like 81% to 98%. So in this bus stop, 98% area will be missed by a sidewalk sidewalk reliant person compared to a person who doesn't mind to share the road. So on average, in Columbus, we found that the gap is 45%. So the sidewalk network provides 45% less coverage than the road network on average in the Columbus. But if you look at the spatial distribution, it is good at the center because we have a lot of connectivity. We have a lot of like multiple transit stuff, very good sidewalk network coverage. And as we go the further to the periphery, there are a lot of like suburbs or like sprawl development. They purposefully didn't build a sidewalk, or they could not maintain the sidewalk, the quality of the sidewalks. So for different reasons, we don't have the sidewalks at mostly at the peripheral area. But this picture is not like as binary as it seems. I'll get to that very soon. Like the further is worse, the center the better. It's not like that. There is more story. So yeah. So please, the next slide. Here, as I said, the gap in the healthcare access and grocery access, we just flagged all the bus stops if they provide the equal access. So the green colors are equal access, good. The orangish color is less access, and wherever we don't, we have the violet. That is, we didn't have any POI or any healthcare or any grocery within the buffer. So those are out of my concern. So again, we see the mostly the central area and the major transit corridors. So if you look at the grocery access, there is a, center. There are some corridors of the transit lines. Like if you're familiar with Columbus, there is a North High Street, Summit Street. Then on the horizontal plane, we have Broad Street, very good transit facilities. Then Long Street. So these major transit corridors, no matter if they're like expanding from the center or like wherever they are providing very better access. Also at the center we have good access, but at some areas at the periphery, close to the periphery, we have like low access. So we found that 39% bus stops in Columbus provide less access to healthcare, and around 29% of bus stops provide less access to groceries. And another simple measure, just the sidewalk gap, not accessibility. The like third map on the right. That is from a bus stop within a 1,000 within a 1 kilometer travel distance, how many miles of streets are not covered by sidewalk. So we found that 3 miles out of every 10-mile streets around bus stops in Columbus have no sidewalk. That's on average. That also can have like the spatial distribution, as we can see in the picture. Um, but that is the statistics for the whole, for the city. That is 3 miles out of 10 miles. So, yeah, can we go to the next slide? Yeah, thank you. So up until this point, we just showed the accessibility gaps and the its spatial distribution. Now we are connecting these gaps with sociodemographic disadvantages or social disadvantages. So here, I just want to familiarize you guys to with these colors. So that's the bivariate map. You all are pretty familiar with this, I suppose. And the x-axis is the excess gap, where the high means bad, high gap. And on the y-axis, we have social disadvantage, which is again the high means bad. So the red is the worst, where we see the cumulative burden of that bus stop or people in that bus stop also has a high social disadvantage and high excess gap. And this light violet is the best. And we have these two colors with like high gaps but better social advantage, and low gap but high social disadvantage. So what do you mean by social disadvantage? We pick four variables. Those are on the top of the maps. Percentage of household with no vehicle, that matters because those are mostly reliant to the public transit. Percentage of people with disability, that also matters because those are relying on the sidewalk mostly if they use wheelchair. Even though if they don't use the wheelchair, they, if they're blind, they use some stick. They they are very much like relying on the sidewalk. Also unemployment rate and percentage of color, people of color. So we found a couple of interesting things from these maps. Um, so one thing, first thing, again, the center is blue, which is like we don't have much excess gap there. The excess is good, but we have high social disadvantage because those are like downtown areas, not like not the place for like mostly the employed people or white people, mostly the percentage people of color, unemployed people, and how people with no vehicle live there. So we have disadvantage, but the good sign is that we at least have the good access. So the main finding I got from this map is that the contradiction of our common intuition that okay, the center area is best, and as we go further we get worst, or in terms of gap. So here we found a different picture. I just want you to see the see the the yellow color, that is high excess gap, but low social disadvantage. We see that the many peripheral areas have that, mostly at the upper left quadrant of the city. That is like mostly areas for affluent people, where they do have very high access gap, but that doesn't matter for them because they are very much affluent people that they purposefully, their communities and their neighborhoods have purposefully sort of rejected the sidewalk, and um, like also the network transit connectivity is not good there. So even though that looks bad, it's not actually bad for them if you think from the perspective that they have means of transportation, they are very much employed and very much affluent. So on the so if that was expected as the picture of the outer belt, and the inner belt is the blue one, then we found the red ones in the middle of these two slices. So that was the interesting finding for us. That is the most burdened people, who has both the high access gap and both the social disadvantage. They don't live at the center, they don't live at the all the way to the periphery, they live somewhere in the middle. So if you look at these maps, the household with no vehicle, there is a chunk in the middle between the yellow and blue. Again, for percentage of people with disability, the red ones are distributed between the yellow and blue, also for the other tools as well, in sort of different ways, but mostly the picture is the same. The exception is at the northeast, sorry, northwest part, which I said, that is the affluent neighborhoods, a couple of affluent neighborhoods, and some other cities. Not only Columbus, we have Hilliard, Dublin, couple of other cities as well. Those are also very high class areas. So, next slide, please. So, that was our mostly finding. So, this study actually calls, first of all, it calls for the improvement of sidewalk for the city. We found that like 3 miles out of 10 miles don't have the sidewalk, and also like we found many gaps in accessing the healthcare, in accessing groceries, or just the simple spatial coverage. So it calls for improvement for the sidewalks, for equitable transit experience. Also, when we go check the association with the sociodemographic characteristic, it underscores a nonlinear relationship, because as we go to the social advantage, um, thus more advantaged people have more accessibility. It doesn't work like that. There are some nonlinear associations between the accessibility and sorry, access gap and the sociodemographic advantage. Also, as I said, that our finding contradicts with with a common intuition that people in the less affluent neighborhood suffered the most from reduced accessibility due to lack of sidewalks. We identify instead a tier between the central, most vulnerable, and the peripheral areas who are most affluent, that suffer from the cumulative burden of the excess gap and vulnerability. And finally, these maps are also suggestive of strong linkage of first mile, last mile accessibility and with the city's historical and post World War, Second World War development pattern, major transit routes, and urban morphology. We focus at these because the same findings might not hold for other cities, because we saw the transit lines, transit corridors, major transit corridors, they play a big role in provocating the implementation of sidewalk works or maintaining good sidewalks. Also, the construction of the highways, the I-70, the I-71, those two highways passes through the center. So a couple of neighborhoods were actually destroyed when during its construction. And the affluent part I just showed in the map, at the northeast, that part was mostly protected from that construction. So the development pattern after the World War, that also has a profound impact on the long enduring inequality of sidewalks or sidewalk works in the city constructions. And also the historical redlining, as I showed, the affluent part, um, and also like Columbus is a pretty interesting example. If we can divide Columbus vertically along mostly the North High Street, so the left part of the west part of the North High Street is very very affluent people, and the right at the right part or the east part of the North High Street has the opposite picture. So this picture is carried to many sociodemographic studies, be that crime, be that like air pollution, be that accessibility to transportation, environment. So the effect of redlining or the historical development, historical inequality, that also has something to do on these findings.